Devin LuBean. I'm a Senior Director of UX at Domo. I work a lot with data and.
I'm Alan, designer at Adobe.
So today, to kind of kick things off, we wanted to tell you a little story about JC. Some of you might be familiar with a story like this. So this morning, JC's PM came to her and said, hey, we need you to design a dashboard for the web analytics on the website. Can you do that for us? And well, JC was a little surprised by this because she doesn't really do data design at all. And she thought, well, I've never really designed a dashboard. And just because I'm a designer doesn't mean I can design data too. And on top of that, PM told her it needed to look good. So I'm sure many of you have had a situation like this where you're told to take some data and make something that looks good. In JC's situation, she didn't know where to start and what to do. She kind of felt like she didn't even know what steps to take. So today we wanted to talk a little bit about this and talk a bit about why JC wasn't necessarily equipped to handle a problem like this, but in reality she is, and we'll get into that in a minute.
All right, so one of the fundamental things I like to talk about when I talk about any type of design is feedback loops. And this is the idea that we as people, when we're interacting with software or really anything, rely on some information coming back to us to know how we should interact with that thing, right? When you pull on a door and it doesn't open, that's a feedback loop that tells you were supposed to push. And as a designer, we can learn from that and say, oh, maybe I should make the door look like you should pull or push it, depending on what you want the user to do. But today I want to use an example of creating a feedback loop. And the example I want to do is the color picker. So as designers, we've all used color picker. Even if we're not designers, we've used the color picker as a tell a computer the color that we want. And sometimes color picker will look like this, right? Computer needs three numbers, needs a red, a green, and blue value. And from those three numbers, it can return a color. But if you've ever tried to get a specific color out of one of these pickers, you know it can be a little frustrating. Playing around with these numbers, you're really not sure what they mean, how far they go. And so we can improve the feedback loop here by improving the interface. And one of the first things we might try is make them sliders, right? Now I at least know the max and min for each of those three colors. I know they go to 0 to 255, and I can drag them around and start to interact with this a little more intuitively. But we can do better. We can reinforce what each of the sliders are by putting color behind the slider itself, right? You're putting more red or blue or green into that color, or you're taking it out. And this is okay, but if we're using a computer as the input device, we can be responsive. And this is where we take a big leap forward and we make those sliders adapt to what the color currently is. So now the colors that we display on the sliders represent what would happen if I moved any one of those sliders. And once I let go of the handle and I finished moving it, all the sliders update to show me what another move would do to the color. And this is, like I said, a huge step forward. This is way better than what we had before, but it's not without its flaws. If I want, for instance, a color that requires me to move 2 sliders, or heaven forbid 3, I don't know how to get there. For instance, how do I move from this teal to like a dark rust color? I don't know exactly how I'm going to do that. And I can play around with it. I can eventually get there, but we can make improvements there. But we're running up into the limits of this RGB color model. For those of you that have worked with color before, you probably know that there's lots of different ways to represent color. They tend to all have 3 dimensions. But the dimension here is the most relevant for the computer itself. That's what it needs to display the color. But as humans, it's not how I think of color usually. And so we can shift the model to something that's a little more human friendly. One that's pretty popular is HSL, hue, saturation, and lightness. And in this example, our top slider is that hue, and this is a static slider similar to the ones we had earlier on. It's never going to change as you move that slider back and forth. But the saturation and lightness do. They change based on the hue. So I could first make that selection in my saturation and then play around with my hue and lightness to refine my color. Now it's a lot easier to get to that rust color that I was looking for earlier. But we can take it further. We know from elementary school when we learned about colors. Oh, wait, that's a step further. One more step before we get there. The saturation and lightness sliders here always confuse me. When do I use which, right? They seem pretty ambiguous. I can get to a lot of the same colors with those two sliders. So we might try and combine those onto a single color field. There's still two inputs here. We're still providing the machine with two inputs, but we represent that with one handle that I can drag around that space. And that feels better to me, even though it's the same data that's coming out of this interaction. And like I was about to say earlier, in elementary school, we learned about colors and we always use the color wheel, right? Because hue circles back on itself. The top of this hue slider is red, the bottom's red. Let's just bring it full circle and represent that as a color wheel. It looks a little nicer and it creates a more accurate representation of how I think about color and how I want to interact with it. Then we can move that two-dimensional slider to the middle. I want to do one more tweak to this. We've come a long way, but I think there's one more thing we can do here. And you'll notice that the bottom part of that hue and saturation slider is a bit ambiguous again, right? If I want that super saturated color, I get it. If I want white, I go up to the other corner. But if I want black, I can go to either of the bottom corners. That just feels a little weird to me. I don't know exactly where to go. And so we can switch the color model again from hue, saturation, lightness to another model called hue, blackness, and whiteness, HBW. And HBW model, one point is black, one is white, and one is the most saturated version of the hue that I have selected on the wheel. And voila, we've got ourselves a pretty slick user interface. And we could probably keep going with this. We could keep iterating on this, keep trying to tighten that feedback loop between the user and the software, the machine. But I think we can all agree with the selection on the right here is a lot more useful than the just text inputs here on the left. And I'm going to turn it back over to Devin. He's going to talk a little more about the design process and what we're doing when we're refining a user interface or any piece of software.
So you can see, let's go back to JC's story where she's got data. She needs to create a visualization out of it. Think of the data as these fields on the left where you've just got numbers. And then on the right, that's your visualization. In fact, this is exactly what a data visualization is. This is a data visualization, just like a clock or a calendar or there's so many things that you interact with every day that is a data visualization. So how do you get there? So JC may think that she has to do something special to start working on a data visualization, but that's not the case. She can just start by using the process that we're all used to called design thinking. And in the design thinking process, just because it's a data visualization, you can follow this exact as you would for any other design project. So today we're not really going to talk about the implementation phase on this at all. And I just want to credit Nielsen Norman Group. They focus a lot on design thinking, and I love everything that they produce. But as a part of this, we're going to talk a little bit about discovery and exploration and how it might, how to think about it with data visualization in mind. So first in discovery, there's a symptom that we talk about a lot in the industry called imposter syndrome. JC's feeling a little bit of this right now. She doesn't really know she doesn't feel like she knows what she's doing. But in reality, she does know what to do because she's done design thinking so many times in the past. So, she might feel like she has to become this subject matter expert in web analytics to design a web analytics dashboard. But instead, what she can do is she can use the design thinking process to become what I like to call the ad hoc SME or subject matter expert. So that becoming an ad hoc SME is kind of what the discovery phase of the design thinking is all about. You're trying to take the knowledge from subject matter experts and digest enough of it that you can create something for them. According to Six Sigma, a true SME is someone that has a level of understanding regarding their subject that is not common knowledge, and an in the trenches tribal knowledge that makes them valuable in their particular area of expertise. JC doesn't have time to do that at all. She's got a couple of days to get this dashboard designed. So what she's going to do is leverage the SMEs that she has near her to become an ad hoc SME to be able to create this visualization. And where else to find SMEs than amongst your user group? So she's going to take the time that she has, go talk to a couple of users who are SMEs to get as much information as she can. She's going to do some observations and interviews, and she's going to focus on empathizing with the problems that they face. And that's what being an ad hoc SME is about, is practicing empathy with your users. So when JC has gathered all of the insights that she can from the interviews and other things that she's been doing, she defines the problem or I guess you could say the criteria that's needed to address the design. In most cases with data visualization and dashboards, the criteria is that the user needs to get answers to questions quickly when they're doing some form of analysis. And in the industry, that's typically called insights. So users of data visualization are looking for insights. And insights is what that feedback loop that Alan was talking about. You're trying to get information from the system when you put input into it, whether that's reading or clicking on some filters or whatever it is. You're trying to get that feedback and gather insights on what to do with the data. So if JC has been empathizing with the users, she'll understand the types of insights that they're looking for. And she can then cater the design to make those insights easier to get to. So does she need to understand everything about the data? No, she doesn't. She just needs to understand enough to know what the people who are using the visualization are trying to understand out of the data. So just like in Alan's example, where it started with just the basic criteria of what the system needs, those 3 numbers, and then you add more to it to make it easier and faster to get those results without having to understand all of those numbers. And that's exactly what JC is going to do. So in the next phase, this is kind of the designer's bread and butter is the exploration phase. And I just want to highlight a couple of quick principles here to hopefully help you get to a good data visualization faster rather than having to noodle on it forever. So the first one I want to talk about is visualizations identify most with users when it matches the brand or the situation that they're in. So if you have a style guide for data visualization, that's great, use it. There's a lot of design systems out there that go even further than styles, and they provide like what charts should actually look like with labels and axes and all of those types of things. That's great if you've got it. If you don't though, and you don't have a style guide to work with, at least you've got some brand colors. We don't have the time to really dive into how to create a color palette for data visualization. That's actually a big topic, and we could dive into a lot of really cool stuff that you can do there. But suffice it to say, you've got a place to start. Start with the brand at the very least and kind of go from there. The second part is data is really complex. So using foundational design principles is how you're going to help simplify that complexity. So use things like Gestalt and pre-attentive attributes, or just plain old simplification, and do your best to try to make it easier for the user to get the insights they're looking for. So a good example of this is when you've got a chart and some body copy with details in it, don't put a complex background behind it. I used to teach an information design class, and it was surprising how often I would get charts from students who would put like a complex background image and then try to put the chart on top of it. And you just can't understand what's going on with the chart because there's so much there. And same thing with the text that's really important for them to read. So just, don't put stuff behind the chart. If you have embellishments that you're trying to add to create a more aesthetically pleasing visualization or dashboard, make sure that it doesn't compete with the hierarchy that you've hopefully created in the discovery phase through your interviews and other things that you've done with your SMEs to create like an information architecture. You've got that hierarchy set up. Don't interfere with it, but instead make the aesthetics and the visualization and the data play nice with each other. Make them best friends rather than compete with each other. Don't sacrifice insights for aesthetics when you're doing data viz design. And then the third one is make sure that you're choosing the right chart type or visualization type for the data you're working with. Are you trying to show a relationship? Are you trying to show a comparison or a composition or even a distribution? Those are very different ways of showing data. And JC, for example, isn't going to know those things off the top of her head. I don't know those things off the top of my head, and I work in data visualization a lot. So I have a cheat sheet. I go to datatoviz.com. They're pretty good about giving you the pros and cons of each different type of visualization. So that's a good quick cheat sheet to try to get to what the right visualization is. One of the things I like about Data Viz is they have a caveat section, which is really helpful to figure out if, off the top of my head, I think a bar chart would be great for this. If you look at the caveat section, you might actually find the data you're trying to display listed in that caveat. And they'll give you some good options of things that you could do instead. So now that we've kind of gone through those two big phases, the last phase is implementation. We're not going to go into this too much right now. With implementation, your testing phase, your user testing and feedback loop there is a part of this phase. That doesn't change with data visualization. You do that just like you would for any other design project. You show it, you get some feedback. If the majority of people are having an issue with something, you fix it, right? But when it comes to the building and shipping part of implementation, that's where it's very different for data visualization than other forms of design. Typically, you'll have lots of libraries and other things that you're dealing with. That is a whole learning series that you could go into on how to create data visualizations after you've designed them. So we're not going to go into that right now. But once we've kind of gotten through this design thinking process and we've equipped JC with some of these things, she already knows what to do. She does design thinking all the time. She just needs to apply that to data visualization and be aware that there's a few things that are different. And what we're going to do next is kind of talk about some of those guidelines to make sure that you're not causing issues for yourself when it comes to designing a data visualization and to speed up the the time it takes to create it and the quality that you can get out of it. So, Alan, why don't you come up and we'll go to our next section.
All right, so guidelines are fine and dandy, but data viz is hard. Data visualization is difficult to do right. So we're going to give you rules. So you cannot be led astray. This is 100% foolproof rules, data visualization. So here we go with the first one. Excuse me. Chart should always have a zero baseline. If you look around at different guidelines, here we see one from Salesforce. You'll see right there, 0 is where you start. Start your Y there, you start your X there. You can see the same guideline over here. This is what BBC advises. Here's a guideline I wrote for Adobe. Use a zero baseline. And if you do, everything is going to be a lot more legible because numbers start at 0, right? You don't start anywhere else. And one more example here comes from the Urban Institute. So zero baselines, right? Zero.
No. I need to disagree with this one. So there are many cases where 0 is the choice you should go with. In fact, I would say almost every case, but there's a few situations where having a 0 baseline is actually going to cause data distrust. So if you think about things where the majority of the data points that you're looking at are really high in the number value, you're going to start to come to a problem where you can't tell the difference between the different data points if you start at a 0 baseline. So a good example of this, well, here's a few examples of some caveats to using that 0 baseline. So a couple of good examples there. But here's one that I want to highlight here, and this is in Apple's HIG. When you look at data where the majority of it is up higher, like a heart rate monitor, there's not going to be anything below like 30, right? Unless you've got a serious heart problem. So if you're trying to measure the difference of, all right, am I running at 90 and then when I'm working with weights, I'm at 80, you're not going to be able to see the difference between those two numbers if you start at 0. So you need to kind of start a little bit higher so you can see the difference. So you stretch out the top portion. Another good use case is when you're looking at like the hundreds of millions in like business financial data. If you're looking, let's say, you know, the last year to this year, and profits last year were 250 million and profits this year were 247, you want to know the difference between those huge dollars. But if you start at 0, you won't see a difference. They will look exactly the same. So there are a few cases where it makes sense to start. I like to start at the equal distance above and below the range of data that you're given, where it makes sense to not have a 0 baseline. But label it really, really clearly that you're not starting at 0, because that can also be a data trust issue. So just be aware that there's some use cases, okay?
All right, you can use me. Yeah, there definitely are. And now that I think about it a bit more, there are numbers that don't start at 0, right? Like I'm dealing with height, that starts at 0, right? But temperature, like does it start somewhere? Did temperature begin or end? It just goes in all the directions at once. That is 0. It's kind of arbitrary. It's not even the same Celsius and Fahrenheit, right? So, okay. Doesn't always have to start at 0, I suppose. And actually, Vox did this great video. We're going to just play this video for you because I think they summarize this issue quite well. This is important stuff to think about when you're designing data viz.
We make a lot of charts. Of course, charts have axes. Pretty much every time we run a chart with a y-axis that starts anywhere other than 0, someone winds up emailing. See, there's a really famous book, How to Lie with Statistics, and it contains a discussion of how you can create a misleading chart by messing with the y-axis. And it's definitely true. Here's a chart from Fox News, for example. It's a total disaster. But the y-axis dogmatists take it way too far. The big problem with people who lie with statistics is that they're lying to you. It's true that misleading charts are one way to lie, but the English language is also a tool that can be used for lying. And that doesn't mean we should never speak English. Sometimes you need to fiddle with the y-axis to tell a story. So for example, right now, the share of American adults who have a job has fallen to a generation long. This is a really big deal. But if you chart this data with the y-axis at 0, you can't see the change at all. Narrowing the range to dramatize what we're talking about isn't lying with statistics, it's emphasizing what's relevant. The way Edward Tufte puts it is we need to use a baseline that shows the data, not the 0 point. And after all, 0 is just a number like any other. Sometimes to make sense of data, you need to be able to show numbers that go below 0. Halting at 0 in those cases doesn't make any sense, but extending every chart with yours would be crazy too. And of course, where 0 even is depends on units. If you do a chart of a person's temperature in Fahrenheit, you're likely to miss the fever if you just go all the way up to 0. If you redo it as a Celsius chart, it's not quite as bad. But if you switch to Kelvin and extend everything to absolute 0, then the charts become useless. When people are really lying with charts, the main thing they're normally doing wrong is leaving out the context, not leaving out the 0. Go back to that Fox News chart. You never know from this chart the top marginal rate was 39.6% back in the Clinton administration, or that the Reagan administration was 50%, or that back when Eisenhower was president, it was 91%. The missing 0 was really the last of the chart's problems. What they left out was the entire history of taxes in the United States. So just remember, y-axes don't lie. People do.
All right. So let's move on to another rule. And this one is foolproof. If you're going to do a pie chart, and there are reasons to use pie charts, never have more than 5 slices. And there's a lot of good reasons for this, right? Typically with pie charts, you rely on the area of each pie. And because they're arranged in a circle, it's hard to compare one of those areas to another or the angles. And so you'll find time and time in Data Viz guidelines, no more than 5, 2 to 5, no more than 5. It's just the way pie charts work.
I want to challenge that just a little bit. I would say no more than 3, ever. And let me specify why. Earlier, I mentioned something called pre-attentive attributes. Pre-attentive attributes are a way that people look at something and make a mental decision in a split second or less than a second, right? So when you look at a pie chart, if you have more than 5 slices, instantly you can't make any decisions. But if you go down to 3 slices as your max, you'll actually be able to make a decision very quickly. And if your goal is to create a visualization that's for data exploration, not necessarily to tell a story, there's a lot of better ways than using a pie chart to show, the range or size or comparison. So I would say, and you could disagree with me, and that's fine. I would say never go more than 3. And if you need to show more, allow people to click in on a slice and get a bar chart or get another pie chart that divides those up. So never go more than 3. That's what I say.
All right. I still say 5 is okay. BBC agrees with you. They say 3. And you'll definitely find plenty of arguments for using as few slices as you can get away with. And heck, if you do find yourself in a situation where you need a lot of slices, that might be a really good reason to not use a pie chart. Maybe to use a bar chart or something else that better meets those needs. All right, let's move on to another rule. Let's talk about labeling axes. Maybe you want to tell us about that.
Sure. Let's talk a little bit about labeling your axes. So most Data Viz design systems will tell you to always label your axes to make sure that it's very clear what people are looking at. Like we talked about before, data trust is a big problem when it comes to mislabeling or chopping off the bottom of a chart or any of those types of things. So play it safe, always put labels. But I've heard some good reasons otherwise, but I think you should just always play it safe. Put a
Yeah.
label.
You can drop them. You can drop labels in a lot of cases.
I don't agree.
Oh, yeah. You're using my own guidelines against me, but Apple came out with some guidelines recently that demonstrate this quite well. You'll notice they didn't label their X or their Y axis here. And they can get away with it because right there in the title, it tells you what they're measuring and what the time range was, the two relevant facts I need to understand the chart. And I think this works well for simple charts.
Okay, that last word, simple charts, made that statement work. If you are doing a data visualization that has multiple charts next to each other, you've got to label your axes. Otherwise, you could, like that Fox News chart, you could put something next to another one that looks like they're correlated, but in reality, they have nothing to do with each other. But because they're next to each other, you've got to label that they are different. So yeah, Apple, they always make things simple and clean and they only need one little chart. But if you've got multiple charts on your dashboard, you've got to have labels. That's what I say.
All right. Yeah, I'll even go back to my guideline. We do have a slight caveat where you can drop the label, but has to be somewhere. And the chart title is actually a really good place to put a lot of the information. For the users are going to read your chart title and they're going to skip the axis labels. All right, let's go into another one, Devin.
So this one is all about making sure that you're displaying your data in an organized fashion. So you should always make sure that when you're binning a color series, that they're sequential and that they're equal size. And in that way, it helps to make sure that there's no fudging of that data, right? Again, you go back to the data trust issue. These colors, if they're right next to each other, you're not going to see a difference in the two colors. Here's a good example of that. If you've got two numbers right next to each other on this color scale, they're not going to look any different, even though they're different numbers. So if you bin them, you'll be in a much better situation to make it very clear that this number is different from another. Yeah.
All right, let's bin some colors and let's see what we get. So here we've got the gradient. Let's go 5. Let's just divide this scale into 5. Put 0 on one side, 100 on the other. We've got our scale. But even though we have 100 numbers, we only have 5 colors to work with. So let's put a couple, we've got our bins equal, right? Equal bins. That's what you call it when you divide a scale into pieces. Each piece is called a bin. Let's put some numbers on here. We've got 39, 41, 57. 41, 57 are the same color because that's the way we did our bins, and 39 is different. So I can definitely tell the difference between 39 and 41. Night and day, even though they're only 3 apart. But 41, 57, they're a lot further apart than that. Hey, look, this is deceptive. This is just lying. I think you should maintain data integrity. Keep that scale as accurate as possible. And yeah, 39 and 41 are difficult to tell apart, but guess what? They're almost the same numbers, so they should be displayed as almost the same numbers.
I think in a case like this, what's important is that he has those numbers next to the colors. If you are going to not use a binned scale, make sure that you have those number labels with the colors so that you can tell that they're different, even though visually they might be super close. Is that reasonable?
Yeah, all right. So double encoding is what I would call that, right? So anytime you're encoding data visually, whether it's position or shape or color or size, double encoding kind of helps, right? So here you've got the labels to supplement the colors, because the colors alone would be a little difficult to interpret. All right. All right, let's do one more and then we'll move to Q&A. Last rule, months. The bane of my existence, months. Never use them as categories. They're the worst categories. Let's compare February to March. They don't even have the same number of days. In our guidelines, we put this right here. Like, don't use months as categories. They are poor approximations of time. They're inconsistent. And you don't even start to address things like the holidays that might be disrupting your numbers, or the number of weekends in one month that might be drastically different than another month, depending on how those weekends fall. Months are the worst.
Okay. I have a really good, why is it? Hit refresh.
Oh, he's got nothing.
No, no, wait, no. There we go.
Oh, dude. Oh,
And then that didn't work either. Hold on.
We'll get
My
there.
evidence is telling.
all right.
Hold on. Where are we?
Yeah, keep going.
Rule
We're all the way to 5.
5. Okay. Bam! From birth, you were taught that the year is divided into 12 and that there's names for those 12 things. And every financial calendar in the world uses months and days and years, and they categorize them by month or quarter. They don't have the same number of days, and that's okay.
This is why we call this the Gregorian calendar, and we have other calendars called sales calendars, or this is one of my favorites. This is the International Fixed Calendar. No one actually uses this one, but I'm in love with it. There are 13 months, 4 weeks exactly. Sunday is always on the 1st. Saturday is always on the 28th. And then you have a couple leap days that are just baked in holidays. And why, like, this is from 1902. Why didn't we do it this way? This seems way better.
Well, there's another reason why America still uses the imperial system instead of the metric system, right? We need to use what makes sense to the user. Yeah, I agree that in many cases, if you're looking from a day-to-day difference, using months is bad because you are going to have problems where February is a shorter month, and so your profits are going to be vastly different than March. But if you're looking at a whole year, you've got to have something that makes sense to the people that are looking at it. So it's okay to use month when you're looking at a larger scale. If you're comparing days though, yeah, that's a problem, for sure.
All right, so be careful with months. Maybe we'll leave it at that. All right. We're going to do a couple minutes of Q&A. So if you have any questions, maybe we come up to the mic and see your question up here so everyone can hear. After questions, we're going to take a 5-minute break and we're going to do a workshop. We're going to get to play with Play-Doh, so it should be pretty fun. Let's start with Q&A. Come on up.
I can pass it around.
Oh, that works too.
Yeah.
Okay.
I'll just stand here so everyone can see me. I'm already up here. So I almost the top here.
Come on up.
Feels weird if I don't face you guys because I'm asking you a question. Well, it seems like to me, this might be a simplification. Also, I got here 10 minutes late, so that's a little embarrassing, but that design thinking and the context is the most important, like who your audience is, what the purpose is, what's your objective. So I was kind of curious, what would you suggest to improve your design thinking, like being more observant, being more careful, like what in your experience, kind of like, does that make sense?
All right, I'll go first, I guess. I think that's a great question. For me, it really comes down to objectives. So it's hard to apply design thinking if you don't know what you're trying to accomplish, right? It's the Alice in Wonderland thing. If you don't know where you're going, it doesn't matter a heck of a lot what path you take. But if you do, that becomes how you evaluate everything you do. So you explore, you try some things, you experiment, and then you say, did that get me closer to the thing I was trying to accomplish, right? In the color picker example, we're trying to tighten the feedback loop between user and machine on, creating a color. If the objective were different, if I was trying to quickly get a close color for a presentation or like in a Word document or something, I might just have a grid of 9 colors. That might be good enough, right? If you don't know the problem, the solution is going to be very elusive. Does that help at all?
Yeah, I need to echo that as well. Like, if you don't understand what the user is trying to accomplish when you start a Data Viz project, then yeah, you're just going to spin your wheels and never come to a good result. And it's going to take a lot of time to design something random, hand it off, get some feedback, and it's just going to take forever. So what's important is talking to the users, trying to figure out what insights they're trying to get. If they're trying to figure out like the number of visitors at any given time for a web analytics dashboard, then number of visitors should be the most prominent thing. But if you ask the users what they're looking for, like, I don't know, I just want to see what's happening on the website, then you need to maybe think about having a couple of pages to your dashboard. One that focuses on an overall view of what's going on, and then separate pages for each of the individual things so that they can do an analysis and find the insights they're looking for. So design thinking always, but as a part of that, it's all about trying to find that context. What are they looking for? And in Data Viz, it's going to be a little different. They're not necessarily looking for what looks good all the time, even though they ask for it. Often they're trying to get answers to their questions. So, all right, other questions?
I got a question.
Yeah.
So sometimes the dashboard isn't always the right solution. What you're talking about, using design thinking, making sure that we're getting to the right conclusions, the right hypothesis. I wonder, what are some of the strategies you employ to make sure that the data that they're using is actionable inside of those tables? Because ultimately we want the user to be able to do something with the data, rather than look at the data, look at the dashboard, forget the data, and then go do their work somewhere else. So that's one question, just the first part. And the second is, how do you measure success inside of your data visualizations? So I'd say you spin up a dashboard, you've gathered all the insights, you're rolling. What are some things that you measure, some metrics that you say, now we know that it's successful?
Yeah, so this, I love the question of like, do you need a dashboard? Because most people that ask for dashboards don't need dashboards. And if you dig deeper on the problem they're trying to solve, again, it comes back to like, why do you need a dashboard? What are you trying to do? You might get an answer like, well, I need to know if I'm hitting my revenue target every week, right? And tried really hard not to say month there. Success. I want to know if I hit my revenue target every week, right? Okay, and a dashboard will do that, yes. But it also means you're going to have to load this dashboard up every day and see, are you on track or not? And you're also going to have to equip that dashboard with what your revenue target is. So it's not just the number, it's the number relative to what they're trying to accomplish. And if you have those two values, why don't you just have an alert that tells you on your phone when you are significantly above or below the expected results of any given day, right? That would serve the same purpose without a dashboard. And bonus, you don't have to load up this specific web page every day to check on it, right? It's kind of like a fire alarm that's telling you there's no fire all the time. Like, I just tell me when I need to look at you. Like, tell me something when it matters, not all the time. So I don't know, that's an example of a problem that is solved without having to build any data visualization in that case.
So that alerting use case was exactly right. So also, when it comes down to a project you're given that's data viz related, they say it is sometimes if you can dig deep enough in your discovery phase and ask the why questions, use the 5 why method. Why do you want a dashboard? Well, I need to know this. Okay, why do you need to know that? Well, I need to know these 3 things. Oh, okay, well, I don't think you need a dashboard then. We just need to have an alert, or maybe you have a dashboard, but it's as simple as 3 KPIs and that's it. So it's all about in that discovery phase trying to figure out what's going on. To address your feedback issue question, I think when it comes to like a data viz, like if the solution is that they need a data visualization or a dashboard, I typically care about 2 main things. Are they interacting with it? Like if they're bouncing right away, maybe they're checking it, weekly, but they never click on anything, then maybe there's a question that needs to be asked is, are your questions being answered and that's why you're not interacting with it? Or are you interacting with it, or are you not interacting with it because you don't know what to do or it's not valuable? And then the next thing would be is, at least in, for Domo and our product, I like to look at exports to see if they're using it. So are they taking screenshots? Are they marking it up? Are they adding comments? Are they saving it as a PDF or saving it as a PowerPoint slide or something like that? That behavior tells me that they found insights. So are they using it and are they finding insights? Those are kind of the 2 things that I like to measure to see if a visualization is successful. Did you want to add that?
Platform thing. So I guess one other thing I'll add is with data visualization, you can't get away from the data half of that sentence or that word. And often we look at the wrong data. So I don't know if I'm going to hit my, revenue target for this week, right? Is the question you're trying to ask. But revenue is like the lagging indicator of lagging indicators, right? You need to go up the pipeline to like what leads to revenue? What is the thing that actually you can attribute to revenue? And the further you can go up to the leading indicators, the more advanced notice you're going to have that there's a problem that's arising. And so sometimes it's a matter of collecting better data or different data to get the answer that's more useful. And, it might come down to leads or something, right? And leads aren't as fun or interesting to the CEO, but if you can show that like when leads go down, revenue goes down, then they'll get it.
There's a question in the chat. Sorry. Okay, thank you.
And then
How do you balance multiple charts visually as well as in terms of data on the same page, like a dashboard? Could you give examples of some of the complicated dashboards you've worked on and some design decisions that drove the solution?
So that's a good one. It can get really complex when you're told that they need to know all of this information, and the only way to show it is a visual chart, and you have to cram all of those into one view. That is a problem. A couple of things that I found really successful, and this is kind of the same thing with most web design, is try to find sections that you can categorize your visualizations in and make them look different. I like to use color to make a difference. So all of the financial charts would use different hues of one color to highlight main things. And then all of the, web analytics stuff would be orange or something like that. So use color to differentiate the difference between this section and another section if they have to be in the same view. But like I mentioned earlier, sometimes the best solution is to just have separate pages. Have a really nice landing screen. That's something that I found a lot of success with when you get this request of, oh, we need all of these things. We need all of these answers. And you're like, well, let's simplify and simplify. Sometimes that just means you need a landing page that has maybe 1 or 2 KPIs from each page. And then you click on that to dive into that next page and get more information. That's kind of what I found is the most successful, is to divide it up into pages. So when we did our COVID tracker a couple of years ago, it was just one page when it started, and it was gigantic. Like you could scroll forever and just get more and more and more information. And we got so many complaints of people like, it takes forever to load. I'm like, I can tell you why it takes forever to load. It's a huge page. So we came in and we created a categorized organization of the different types of data that people would be looking at, or the different types of questions or insights that they're looking for, and created navigation for each. One was finance related, one was population related, one was hospitalization related. So we divided those up. The main page had some major KPIs for each of those sections, but a big, huge call to action to look at more information about this. That's kind of the solution that I found. But again, if you can avoid having as many charts, that would be great. Eliminate the data visualization as much as you can to simplify and make it a better user experience.
Yeah, I don't have a lot to add on to that, but I mean, this is where designers shine, right? We employ the things that we've learned as a designer to use color to our advantage, use layout and typography, and interaction as well. I mean, you kind of touched on this, but like progressive disclosure is this notion that you can hide a lot of information behind a door, and when someone wants to open that door, you give them more, right? And that door can be as simple as a tooltip that appears on hover, or as complex as a link that opens up a whole nother set of reports that you might want access to. I think there was one more question, at least.
There's one in the chat.
Oh,
still, too.
okay.
So if no one, does anyone have one here? Okay. How do you visually tell someone they can interact with data, whether in an app or in a browser?
I don't know.
I'd say utilize your pre-attentive attributes if you can. So one of them is motion, one of is a pre-attentive attribute. So if you can scroll something, do a little bump animation that shows that there's more data underneath, or make sure that you're cutting off at a certain point to show, oh, that bar is half the width of all of the other bars. So that means that I can scroll it left or right or something like that. But in the end, most of the time I'll use like a tooltip or a guide that pops up and says, hey, scroll or click and drag or something like that to show that they can interact with. But if there are affordances that are pretty common in design, like, you know, a dropdown has a caret, that's helpful, or something that has a box around it can typically be clicked on, and so people will explore in an exploration way, click on it. But sometimes you just gotta tell them with a tooltip or a guide or something like that. A video works well.
Yeah, that's fair. I will say, when I first got into data visualization about 15 years ago, it was kind of the heyday of interactive visualizations. All the big news offices had big, groups that created these really interactive, really fun visualizations. And one of the reasons you don't see that as much anymore is because they found by, looking at what users actually did, that no matter what they did, people just didn't interact with them. Upwards of 80 to 90% of their users loaded it up, looked at it, and moved on without interacting with it, and they missed 90% of what was there. And so in journalism, you still will find interactive graphics from time to time, but most of the graphics you see are static because it just what they weren't getting any return on the investment. The interactive ones were a lot more difficult to build, and people weren't taking advantage of them. So sometimes, I love interaction. I think interaction is really powerful, but sometimes you're going to bang your head against that wall all day long, and your users just don't want it to interact. They want an image.
We live in the clickbait world, right? And so an instant graphic is what, like Alan said, that's what they're looking for. So I would say, go back to your users, your user group, and figure out what they need. So if your user group is IT professionals, you could probably say that they will probably interact with it, right? Because they care about the ins and outs of things. They care about like issues, alerts, all of that type of stuff. They're going to care about it. But if your user group, your potential user group is like 18 to 25-year-olds without any kind of category beyond that, they're used to clickbait, so try to make clickbait. I'm not saying sorry, let me rephrase that. Clickbait has a connotation of lies or, you know, misleading information. What I mean by clickbait is something that they can look at that inspires them very fast. So utilizing your pre-attentive attributes would be a big part of that. But yeah, a lot of people just don't want to interact. They want to look and scroll, go to the next thing, go to the next thing. So do what you can. Sometimes that might mean that you have to flood your market with even more so that they get more of that information. Because if you're only going to get 10% of the information with a single chart, then maybe you need to have 5 or 6 charts and think about, you know, sending one chart one day and then the next chart the next day and then the next chart the next day to try to build up that knowledge. I just think you kind of have to go around that idea that they're not going to interact with it, because they don't. People don't click things if they can avoid it, and people don't read much if they can avoid it. So just be aware of that. It's that instant gratification that you're looking to fill that space. Any other questions? Yeah.
So with dashboards, it seems to me like a lot of people would have an established flow down the path. I feel like we talked a lot about when someone wants something. How do you guys hand off like a change to an already existing workflow? Like with that color example, the square A to cell one makes a lot of sense to me. I didn't understand the triangle one. But ultimately, the triangle one's better. How do you communicate that and like onboard your users to switching to something better?
Yeah, so something that I like to do, and you can call this silly if you want, but I like to try to bunch together changes as much as possible. Like if the best solution is to interrupt their current workflow that they deal with every day and make it better, change it, it's going to be painful for them. So a lot of people would think, okay, well, let's just give them a little bit at a time. You know, we'll roll it out over 2 years or something like that. And eventually it'll get to that triangle with the circle around it, right? I really believe that that's the wrong path to go. You want to cause as least amount of pain as possible, especially if you're dealing with large corporations or groups that it's even more painful because they have to redo their training materials or they have to redo the devices that they have to deal with. Try to bunch as much together as possible and ship it all at once, so that the period of pain, it might be a little harder than little bits of pain throughout 2 years, but that one concentrated period of pain is going to be much better for their long-term happiness as an employee of whatever company you work for. So that's kind of the only thing that I can really think of there is try to only do it once if you can and do it the right way that one time instead of a bunch of times over a long period of time.
Yeah, your existing user bases are always resistant to change. I mean, look no further than any social media platform. Pick your poison, Twitter, Instagram, Facebook. When there's a UI change, what does everyone do? Complain about it. It's the worst. I can't find the thing I always do to, like, we hate it, right? And then 3 months later, we don't even know that it changed. Like we learned, right? And so you have to balance that. You have to decide, is the return of that additional friction you're putting on your user base worth it? Is because you're gonna have to endure that pain to get them over their old usage patterns onto new usage patterns. And so it's difficult. One of the best things about creating net new software is you don't have to worry about any of that. You can change stuff all day long because all your users are new. When you have an established user base, change is very difficult. And so that's why you will see, onboarding experiences. I mean, you can only imagine how much time and energy a company like Meta invests in any update they make to their software. How much time and energy do they put into like, are we going to do this? How are we going to message it? How are we going to onboard people and so on? So it's a difficult problem. And I guess at the end of the day, think about that as a design challenge in and of itself. Like design challenge 1, what's the better UI and how are we going to change it? And problem 2, how on earth are we going to get people to actually like this and use it?
I think a key to address that issue of the complaints is if there are hierarchies in your user base, go to the higher levels of the user base because they'll become champions of the change. So what I'll often do is if there's like an influencer in that space, get their involvement, make sure that they've actually been an advisor on what the changes are. And if that influencer is one that's like, actually, I really like these changes, I think they'll be really good, and you verify that with multiple different influencers, they're going to be pre-sold on the idea of changing. And then when you roll it out to the greater populace, they can actually say, hey guys, it's actually awesome. This is a great change. It lets you do blah, blah, blah. Or I'm actually able to get greater insights from my data because I don't have this giant dashboard anymore. I've just got an alert that it sends me twice a day. Whatever the change is, get the influencers to sell it for you. Because if you just roll it out to everybody, you're just, like Alan was saying, we're resistant to change. We're just going to get complaints. So.
Let's do one more question. There's one in the chat. Is that okay?
Yeah.
Okay. What advice do you have for designers interested in career transitioning into data?
I need to think for a minute.
Okay, I'm gonna get, yeah.
Yeah.
Do you want me to
Go ahead.
repeat it? Is that okay? What advice do you have for designers interested in career transitioning into data?
Well, it depends on a million things, like what are they transitioning from and what kind of data do they want to get into? But I can speak from my own personal experience. When I joined Adobe 12 years ago, I realized I needed to up my data viz chops because I was working with the enterprise side of the business and there was a lot of charts in the UI and I knew they were bad, but I didn't know how to make them better. And so I got involved. I read the books, there's lots of resources out there. The Vox video, right? Like reference Tufte and there's Stephen Few. There's lots of really great thinkers in that space. So there are a lot of resources. But two things I'll point out, and we've got some slides. I'm gonna skip ahead to. Yeah, there we go. There is a meetup here in Utah, the Utah Data Viz meetup. We have not been super regular since COVID, even since our founding, if I'm honest. But we do have events and they're free, they're local, and this is where we will have conversations like this and we can talk through problems, we can network with one another and, elevate our skills as a group. Now, there's a broader organization called the Data Viz Society. They're most active on Slack, at least that's what I found, but they have a publication. They have a lot of great resources, and we have a Location Utah channel in their Slack, where again, we can connect more locally and talk through some of these things. Yeah, so I would start there. And if you're looking for specific things, specific book recommendations or software to use or tutorials or whatnot, these places are great places to go with those questions and you can get answers.
I'd also recommend finding a place or a person that you can go to as like a mentor in the space. And sometimes what's helpful is to do a bit of exploration on your own. I remember a designer that we interviewed many years ago at Domo. We kind of hired her on the spot because she took personal life events and created charts out of them just for fun. She now works at
Pentagram.
doing data viz for them. She's amazing. Sarah K. Miller, right? Sarah K. Miller.
Yeah.
She's awesome. But sometimes if you want to make a transition to do more data visualization instead of like websites or other things, start doing some on your own and show that you are interested in the space. When we're looking for designers, often we interview 100 of them, and most of them have never done any data viz design before. And so we kind of have to gauge based on their the work that they have done. Actually, they did a lot of work with typography in this one. They've done a lot of work with, lots of interactivity on this one. Those would work really well with data viz. So we have to do that. If I see a portfolio and they've got like a couple data viz projects in there that are just fun and playful, I'll read those way more than I would if they just have a bunch of websites or apps that they've designed.
Yeah, Sarah K is awesome, and credit where credit is due. She started the Utah Data Viz meetup right before she moved to Chicago. And the only thing I'll add to that is do it, practice it, right? For me especially, things don't really click until I use them. There's 4 types of axes that you use in data visualization. And I was visualizing, I probably made 100 visualizations before they all really clicked for me. And I don't know there's any replacement to that. I'd read the books, I knew they existed. I had to look up their names all the time, but I never really understood them until I started to use them. And that's one of the things we hope to kind of open your minds to in the workshop. But I'll use that as just a little teaser. The workshop is going to be a chance to practice some of these skills and put them to the test. And without having to worry about software, because we're just going to be dealing with Play-Doh and paper and pens. It's going to be fun. First, let's have some lunch, and we'll introduce the workshop in just a few minutes once everyone has some food. And yeah,